Good afternoon, ladies and gentlemen. My name is Karel Hendrych. I'm Juniper system engineer, working in the region, covering mostly security topics, meaning I'm the guy looking after firewalls, VPNs, third-party integration, usually for both enterprises and service providers. Today, I would like to have some, let's say, introduction into what's going on in Juniper Labs to give you a short update about the current happenings within the security portfolio. Then in the second step, I would like to speak a little bit about so-called security intelligence, which is our latest product for making, let's say dynamic security as fast and scalable as possible. Then, as my presentation is not really about products as such, so you won't be seeing many boxes, still I put there one slide about one particular product. So there's going to be one slide about a product. Then I would like to tell you what's new in the IPS realm, so in particular about some IPS catch rates. And one of the last items is going to be automation, which is perceived by Juniper as a really important piece. And last but not least, I would like to tell you what's possible, like next step, so regarding testing, cloning, our support, etc. All right, so about this one, you may have heard from our competitors that Juniper is somehow leaving the security market, not committed to security, etc. That's not true. That's not true at all. Juniper is highly committed to the security market by innovating and serving usually the biggest customers out there. So we are the first vendor who delivered 100G interface on a firewall, like general availability, public availability, and we are shipping right now firewall product capable of running 2 terabits per second iMix. So it's there on YouTube. You can check it out how a Juniper device performs 2 terabit firewall per second. So we are there, and we'll be there for quite a long time. All right, so what is the firewall reality these days? These days, firewall is usually the static roadblock, right? And it's about mitigating the guys who are trying to find some way around. However, to mitigate these guys, it's important to react fast and to be scalable. So if there are 1,000 guys trying like this, you need to do it within seconds to get rid of them and enlarge your roadblock dynamically. So that's what we are doing these days. And how we are solving the problem. First of all, we at Juniper believe that you need to stop the attacks, or you can prevent the attacks by only using the best-in-class security. I'm not necessarily saying it has to be Juniper firewall. It has to be something which is forming the security solution as such. So firewall, probably the best-in-class SSL VPN, the best-in-class DLP, best-in-class antivirus, best-in-class host IPS firewall, SSL decryptors, CM system. So, frankly speaking, there is no single box device on the market able to fulfill this. We at Juniper are usually working for big customers, so having separate firewall, separate appliances for different tasks, and this is the way to go at scale, right? And usually, out of that one, you will get the best results, especially if the things are integrated together, if they are capable of speaking together, like you can get data from CM or DLP, put it onto your firewall, and make the firewall to do the enforcement. That's what we believe in dedication of the tasks and integration that performs and is secure at scale. I was already speaking about performance and scale. So what we are doing are, especially in the higher end, scalable platforms. So you have a Juniper chassis device, which is giving you some certain performance. If you need to boost the performance, you put additional card, and you are getting more power on a certain interface. That's what we are doing. And it's always also about predictability of the performance. So in Juniper datasheets, you can find what is the performance, for example, if you enable IPS. Every vendor out there is dropping the performance if you are enabling the features. And the differences are about how much is the performance dropping, whether it's 50%, 30%, or 80%. That's the difference these days. I can tell you that we are not dropping that much the performance if you are enabling the features. And if you need more performance, you can put more equipment into the chassis, and it will give you, again, the performance what you need. Essentially, we are doing parallel computing within our systems. And then we as Juniper have been serving since day one critical assets, internet exchanges, critical customers like air navigation controls, power plants, other utilities, etc. So the network has to be usually always available for our customers. So again, the way how we are doing the things is to have it robust and always available. Regarding evolution of the firewall, we passed already the stage of NG firewall, and now we are talking about something what we call dynamic adaptive platform. So this dynamic platform is some building block of the complex security solution, which is capable of receiving the intelligence data, not just from Juniper, it can be whatever third party, and enforce, either to redirect, drop, you name it. So what we call today, it's dynamic adaptive platform. Later during my presentation, I'll tell you how we are doing the things. So what is the architecture these days? Usually we are positioning high-end SRX firewalls to the data center, service provider, edge, internet edge, you name it. Usually having some provisioning portals, customer portals for specifying tenant rules, tenant settings. The virtual security, single tenant is usually done by a virtuousErics product, and multi-tenancy is achieved by virtuousErics as well within hypervisors like VMware and KVM. Plus, branch office remote locations are being served by branch SRX product, which is designed for distributed enterprises. So hundreds, thousands, tens, you name it, devices spread across countries, continents, and having usually IPsec tunnels built to center, centrally managed, sending logs to the center, receiving central policy, etc. So this is our standardized way how to treat security, network security at our customers. You may have seen this slide before. This is about the Juniper Day 1 architecture. Essentially, what we are doing at Juniper, we are clearly separating the control plane and the data plane. Essentially, the control plane is never ever involved in the transit traffic processing. The difference is following. If you have the traditional system, the traditional machine, like this, then if this machine gets under some sort of attack, like traditional PC architecture, you may have troubles even managing the things. Some real-life story, customer of mine suffered last week ERP flood in their network of 1 gigabit per second. And they had troubles with the network, naturally. There was a huge flood all over, misconfigured switching equipment, but still they were able to log on their Juniper firewall and take some actions. If that was a traditional PC architecture, probably they would need to disconnect the wires, shut the ports, and take the action. So Juniper architectures are always honoring either virtually or physically the separation of data plane and control plane. Regarding the product line, we have, like I was speaking before, smaller devices intended for distributed enterprises, small campuses, maybe even smaller enterprises, Internet Edge, and then the line goes up to something called SRX 5800, which after a couple of years and evolution is 16 rack unit 2 terabyte firewall. Not necessarily day one 2 terabit performance, but the beauty of this one is that it can be scaled using 12 slots, meaning that you can get some chunk of the performance for the day one, and then later on it can be easily upgraded to provide that performance. These devices, starting with SRX 1400, are the platforms having the clear physical data plane and control plane separation, and they have attributes of parallel computing and scalable platform. Somewhere in the middle, there is a platform called virtuousErics, covered in one of the next slides. Regarding evolution of SRX 5K, what is behind the slide? When SRX 5K was released, like 7-8 years ago, it was a platform supporting something like 4 million concurrent sessions, some tens of gigabit of throughput. But during evolutions like the 2nd gen and the current 3rd gen, it is platform capable of mentioned 2 terabits, 100 million concurrent sessions, and by end of the year, even multiplying this 100 million sessions to next level. So it's a perfect data center scalable platform for big enterprises, service providers, acting like a Swiss knife in the networking security. So not stateful firewall, a huge IPsec concentrator, IPsec, IPS, you name it. All the features are in there. Regarding virtuousErics, recently we have released a new virtuousErics architecture. So instead of having traditional virtual machine, we have released a sort of interesting approach using nested virtualization. So essentially, the virtuousErics control plane is a nested BSD machine running within Linux. And the actual processing is happening on the Linux software thread, and optionally, technologies like SRIOV can be used for speeding up the processing. What is it about? So SRIOV is a technology where the guest machine can using the appropriate network card and chipset, direct memory access to the hardware. Still, interrupts are being handled by the hypervisor, but the DMA operations are sort of straight. As a result, we have probably the fastest virtual firewall out there. So if you have appropriate hardware, like 3+ gigahertz zone CPU, appropriate NIC, we can achieve on large packets up to 17 gigs per second on a virtual platform, which kind of equals to 4-point-something gigs per second on a single virtual machine using 2 CPU cores. So one CPU core is control plane, the second one is data plane. So as you can imagine, this could be already kind of firewall for some computation pod, maybe smaller in-a-box data center, etc. To stay away from some corporate slides, I took screenshots from my own lab. There you can see two screens with a tool called NUT-TCP. And this tool is essentially producing 10G half duplex TCP traffic, so 5 gigs full duplex TCP. And there you can see on the output of the Junos device ingress packets per second, so 2 times 500,000 packets per second, which equals kinda 5 plus 5G on layer 2. So I would be able to achieve probably more, but the CPU was 2.4 gigahertz, while the synthetic test was on a faster CPU. But still, quite good performance for such a device using SRIOV technology. All right, regarding security intelligence. The first building block of security intelligence is a Juno Space platform, which is a joint central management platform for Juniper products. So essentially, you can manage using that one Juniper routers, firewalls, and switching and fabric equipment. And on top of the space platform, we are putting application. So obviously, security director is intended for managing security, network director for managing switching, and there are also tools for like provisioning of layer 3 VPNs, etc. One part I'm going to cover later on is ability to be controlled externally using APIs and SDKs. Today's focus is security. So the security director is a tool able to manage everything you would imagine from the security world. So it's firewall rule-based, NAT rule-based, objects, IPS, application firewall, UTM, you name it. Last but not least, threat intelligence enforcement, which is the component for managing the security intelligence part of Juniper portfolio. So what is it about? First item, first building block in the simplified schema is Spotlight Secure Cloud, so which is a cloud database providing command and control data, so URLs, IPs, and GeoIP data. This is being sent to the customer premises into a device aggregating the data, which is also capable of accepting customer-specific data, either by downloading some text file or some API push. I'm going to speak about that later on. And that one is centrally managed within the management platform. And then the data is being propagated to either one or distributed set of firewalls. So the key takeaway is that there is single central platform aggregating the data, and then the data are being distributed all over to the firewall infrastructure for sake of consistency and scalability. If you look into the details, in particular, the intelligence data are being sent to a component called Spotlight Secure Connector, represented by a virtual machine. Also, that virtual machine is accepting customer data. Then within either physical appliances or virtual appliances, there are the particular applications managing the firewalls. So the security director, optionally for log management and reporting tool called log director. And everything is part of so-called space fabric, either, like I said, virtual or physical. So the full-blown Juniper firewall management consists of, like, it could be easily 4 virtual machines working together. And then, of course, the Intel is being distributed all over in the step 5. Regarding the Spotlight Secure Cloud Service, it's our own research and third-party data which are being subjected to something what we call internally cascade algorithm, And this cascade algorithm is looking after removing false positives, prioritizing really relevant threats, and then distributing the data to the customers. So it's a smart algorithmic decision what is important for the customers and more, and what is important less. And the algorithm is assigning so-called threat levels to the data. Regarding use cases, the first use case, the obvious use case, is command and control mitigation. So when everything fails, like DLP, sorry, not DLP, the sandboxing doesn't trigger, the antivirus doesn't trigger, IPS doesn't trigger, simply nothing triggers, and the malware is trying to contact some control channel to update itself, get instruction, and last but not least, exfiltrate data, then this might be the last resort preventing some operation. If you take a look, when I took the screenshot, there were like 200,000 records for IPs and about 20K records for URLs, which is quite fairly large database, isn't it? I mean, to be able to deal with that one, parallel computing is needed. So all the connections being set up to high-end Juniper firewall are being dealt in parallel. So you are not impacted that much to some performance drop if you have the parallel computing, which is delivered by the Juniper firewalls. Then, obviously, you can subject to the control some certain users, put some application firewall restrictions on top of it, enable UTM, IPS, and have many profiles dropping above some certain thresholds. So in particular, this profile called CNC-10 is triggering on the threshold level 8 and above. So whenever the IP or URL is scored 8 and above, it gets dropped, otherwise you are logging the things, which is giving you a lot of flexibility how to deal with various assets. So probably engineering assets would be more important than, I don't know, some guest network, for example. Use case number 2 is a quite traditional one. It's a GeoIP, so you can create a dynamic object having the list of countries. This is coming for free with the central management platform. Very easy one, straightforward. No need to explain more. Third use case is already touching the ability of receiving third-party data or the customer data. And essentially what you can do is to have sort of dynamic object within the firewall rule base, which is represented by flat text file residing somewhere on a web server, if you like. So the provisioning can be simple as just putting or removing lines from a text file, meaning it could be a host, a prefix, range, you name it. It scales. So we are supporting up to 1 million records within the custom files to be uploaded to the device. Use case could be that you have some certain blacklist denying everything. There is a list of permitted countries permitting certain services, plus some exception. So instead of logging onto the firewall management or to the actual firewall platform, doing some changes, it's possible just to put the record, the exception record into a text file, and later it gets automatically updated to the firewall. Use case number 4 is my favorite one. This is the API push, meaning that it's not difficult to create a script which is either adding, removing, updating an IP address with given timeout and with given threat level to the certain management platform, and then the firewall is acting accordingly. So, for example, there is a rule base with 2 profiles. One is called SI8. The second one is SI6. The first one is triggering on a level 8. The second one is on level 6. So if you have something marked by your CM system, if you like, with a level of 4, all the services, meaning SSH, FTP, HTTP, are permitted. They are coming through. Then the attack is being escalated to level 6. Only SSH is permitted, and escalation further means that also the SSH is denied. So simple like this, just simple API push based on external data. So my favorite use case is antivirus management signaling. It could be IPS signaling, DLP signaling. Then the firewall can take the right decisions. All right, what would be the enforcement point for this one? I picked intently one platform. It's SOX 5400, 5-rack unit device capable of multi-10G performance and capable of mixture of 1 gig interfaces, 10G interfaces, 40G and 100G interfaces. So it's quite unique platform out there on the market, capable of delivering high speed, upgradability, and interface variety and density. Regarding IPS competitive, we have been working a lot on IPS. There was recently some blog post on Juniper Web. You can check it out. It's public. Essentially, it was about checking out the catch rate, so ability to catch attacks in targeting server services, so client to server signatures with defined hardware, defined software versions, defined pattern databases, and the results were like this. Those differences can be the way around the roadblock, right? So this is my message. Tiny little differences in IPS catch rates can do the difference for the guys getting around various blocks and devices. Professional tools were used, Breaking Point, Metasploit, a database, and tools from Telus, which is Canadian ISP. Last but not least, also working on providing IPS patterns and signatures. Regarding automation, automation is a hot topic these days at Juniper. So what we are doing is we are heavily involved in all the SDN happening, and also we are allowing our customers to external influence the configuration and the behavior of our devices. So by using those 7 Python lines, using a tool called Easy Python, or if you like, there is also a tool for Ruby. You can easily connect to the Juniper device, take some configuration file, commit that one, and change the configuration. As simple like this. Just this one is holding the set commands or delete commands for changing the whole stuff. I was speaking before about ability of central management to be externally controlled. So essentially, what we have is REST APIs, so using HTTP methods. Firewall rules can be modified, IPS can be checked, device can be influenced. So you would probably use this one if you need to propagate single change to thousands of devices. So instead of going box over box, you talk with the central management, and then the configuration change is being spread all over at scale. All right, so what could be the next step? We are giving to our partners, customers, if you like, tools for migrating the firewall rule bases from whatever vendor devices to Juniper ones. Frankly speaking, it's usually a good time to do some cleanup, to do sanity checks whether the things are still needed, and then convert. And last but not least, we are kind of vendor which is happy to show you how the devices are working. Meaning that we have professional labs with professional tools. preferably testers, traffic generators, if you like, capable of generating multi-10G, 100G traffic patterns, and see what's happening, how the devices are performing, if they are stable under the load, if the connection setup rate, transaction rate, concurrent sessions, BPS, PPS values are good, fulfilling the task. So please talk to us, and we will be happy to arrange for you some nice testing and demo of our equipment. All right, I got something like 3 seconds remaining. So thank you very much for your attention, and see you later.